Hi guys, good morning. Welcome to another one of RT Dowlett lectures. And in today's class, I will be focusing on an aspect of CSEC physics, in fact thermal physics, that deals with conduction. Now, the basic concept of conduction that we're going to look at today will form the foundation for CAPE Unit 1, right? So it's a good revision for CAPE Unit 1 students under Module 3, and it's good for our normal CSEC students. So when we talk about conduction, we are talking firstly about a method of heat transfer. So if I am talking about heat transfer, right? Let's review what heat is. Heat is synonymous with energy. And in order for that energy to flow, the body must be going from a higher temperature to a lower temperature. So if I pour hot water against ice cubes, then the heat from the hot water will go to the ice, which is at a lower temperature, close to zero, if not zero, and it will cause the ice to melt, right? And it would raise its temperature. So we are saying here that heat energy goes from higher to lower temperatures. So when we talk about heat energy, we are talking about in conduction two methods, right, that can be used to transfer that energy. The first is by lattice vibration, and the second is by electron movement. So when we talk about lattice vibration and electron movement, let's first give a definition of conduction. Conduction is the transfer of heat energy from a region of higher temperature to lower temperature without the movement of the matter itself. So this is important because it tells us that the molecules do not move, and it relies on the proximity, the closeness of molecules to each other, or in the case of a metal, due to the state of metallic bonding, having free and mobile electrons. So when we talk about conduction, we are talking about firstly, lattice vibration. So there are two methods by which heat can be transferred without the movement of the molecules itself. That's what I mean by the matter itself. So if you talk about lattice vibration, you are considering a state where the molecules are tightly bound to each other. So the molecules themselves are in close proximity to each other. So here, if we apply heat energy, it is going to cause these molecules that are closest to the heat source to gain energy. So you have firstly heat energy being absorbed, and that is converted to kinetic energy. Now guys, because the molecules are fixed in this arrangement, it could only vibrate about a fixed point, right? Now these molecules, when they vibrate, they knock into adjacent molecules. And again, it relies on the proximity, the closeness of the molecules. If the molecules were not close together, then it would be very difficult if a molecule vibrates without physically moving to knock into an adjacent molecule and transfer kinetic energy. So the heat energy is transferred as kinetic energy, and then as the molecules are close together, they cause their neighbor to vibrate. And it is through these subsequent vibrations that you will find that kinetic energy is transferred. And heat energy also becomes flowing from end A all the way to end B. So the heat energy is transferred as kinetic energy, and that goes from end A all the way to end B. So if we are talking about a liquid, lattice vibration would not be it would not be very efficient because the molecules exist in a cluster and it's very far apart, even with a gas. So I can make a statement that the separation of the molecules makes conduction inefficient, because by definition it is the transfer of heat energy, not by the movement of the molecules themselves. So now let's talk a little bit about electron transfer or electron movement. So if you have, let's say, a metal surface, you would have had your atoms. So yes, they would rely on lattice vibration, but you also have free and mobile all around the surface, free electrons here. So when these guys gain heat energy, they will just feel free to move quite rapidly from one end to the other. And that is why we are talking now about metals being better heat conductors than non-metals. And that is primarily because you will find now that free and mobile electrons are ready to transfer the energy because they are so free to move. So there is an experiment that we normally refer to when teaching this topic. So we take a tripod stand and we place different types of metal rods. So I could apply like a copper, iron, aluminum, brass, for example. And you make sure they're identical. Then you attach using pieces of wax matchsticks, right, to the end of each rod, and you heat the bottom of these rods here, and the one which conducts the heat, that is the best conductor, the fastest, would allow the wax to melt, and it could cause the matchstick to fall the first, right? And basically from that you are able to deduce, you know, the range of conductivity. Now when we talk about water, for example, being a liquid, being a poor conductor, there is a very common experiment we normally use. So in this one, you take pieces of ice and using a wire gauze, you keep it suppressed at the bottom of a test tube. You then fill the test tube with water and you apply heat to the top. Now, obviously, if I heat at the bottom, then the heat will circulate through something called convection. But as we are talking about conductors being, that is liquids being poor conductors and conductors being most efficient in solids due to the proximity of the molecules, you will find that when I apply heat energy to the molecules at the top, it will cause the water molecules to boil, right? And when that happens, these molecules, because they are not very close together, what you will find is that they do not transfer heat energy down the body of the test tube, right? And because of that, you will find that it's not a very efficient form of conduction. Okay, so in the next video we look at convection, and a subsequent video radiation, because convection and radiation are also two methods of heat transfer.